Okay, so determine the vector n that is perpendicular to the plane. So when we're looking for the normal vector, it's just the coefficients of these three terms here. So it'll be 1, -1, -2. That is going to be our normal vector. Determine a vector equation of the line that is perpendicular to the plane that contains the point, this point here. So to get the equation of the line, it's r equals a plus kd, where d is your direction vector. Now in this case, we're going to be stealing the n, or the normal vector above, because it's perpendicular to the plane, and we want something that has the direction that's perpendicular to the plane. Next thing we're going to do is we're going to take the point that's given here as our A point, and now we've got a nice little equation of the line. Use your results from question 12b to express the equation of the line in parametric form. Parametric form just means that you've got the term of k left in there. So I'm just going to convert this. So to get x, I would have to do -2 plus k. To get y, I'd have to do 1 plus -k. To get z, I would have to do 3 minus 2k. Obviously, I could have left this out. I just forgot about it. Okay, so you get 1 mark for that one, 1 mark for expressing that, 1 mark for these three equations. So the line L and the plane intersect at point S. Show that the coordinates of S are 2, -3, -5. So there are a couple of different ways that you can do this. Because it's only asking me to show, I'm just going to use substitution. So I'm going to substitute x, y, and z back in up here to our parametric form to get what our k value is. Now, if the k's aren't the same in all the cases, then that means that they are not at the same point on the line, which means that they're not, you proved it's not true. So 2 equals -2 plus k, so therefore k equals 4. -3 equals 1 plus -k, so then k equals 4 again. Z, so -5 is equal to 3 minus 2k. Take the 3 across, that'd be -8 divided by 2, so k equals 4 again. So therefore, the coordinates of S is when k equals 4. I need to make this statement here just to show what I've found, because I've shown that they're, when k is there, but I need to make sure that it's verified as well. Now, I'm not finished because we're trying to make sure that the line and the plane intersect at this point. So I've now proven that this is a point on the line. To prove that it intersects on the plane, I'm going to take the equation of the plane from above, and I'm going to substitute these values in. So it was x minus y minus 2z equals 15. So to test that this is true, the left-hand side should equal the right-hand side. So 2 minus -3 minus 2 times -5 equals 15. So that'll become +10. That's +3, 2. So that is equal to 15, so therefore that's true. So that means that this is also a point on the plane. Also a point on the plane. Now, I'm assuming that you get 1 mark for showing this, 1 mark for making a statement that it's a point there, and then 1 mark for showing that it's also a point on the plane. Okay, now we're going to determine A to S. So, originally, we're given that the origin to point A is equal to -2, 1, and 3. And then we're given that the origin to S is equal to 2, -3, and -5. Now, I'm a little directionally challenged, so every time I just draw my diagram. So this is O to A, O to S, and we want the vector that joins A to S, meaning that I need to reverse the direction of A. So A to S is going to be equal to S minus A. So 2 minus 3 minus 5 minus 2, 1, 3 equals, okay, so 2 minus minus, that'll make positive 4. Minus 3 minus 1 will make minus 4. Minus 5 minus 3 will make minus 8. Okay, use the property of parallel vectors to verify that A to S and N are parallel. So if I look at the directional vectors, A to S, the directional vector is given by this. And N is given by this. Now, if you've forgotten what the properties are of parallel vectors, that's fine. Just look at these two things and see if you can try and come up with something. Now, I can see that A to S is just a scaled up version of N. So I could say that, therefore, parallel as A to S is equal to 4 times N. And then that should be good enough to prove that they are parallel. You've stated that they're just scaled versions of each other. So that'd be 1 mark, that'd be 1 mark there.